Back in 2017, the world of physics was absolutely buzzing. A team at Harvard announced they'd finally created one of the most legendary materials on Earth, metallic hydrogen. We're talking about a discovery that promised to change, well, pretty much everything. But then, the story took a really weird turn. I mean, that's the lead scientist, Isaac Silvera. That's what he told reporters just a few weeks after announcing their monumental discovery. The world's only sample of this miracle material was just gone. So that's the big question, isn't it? How does a substance that could literally revolutionize energy and space travel just vanish into thin air? Was this some tragic lab accident, or was it the first clue that something was deeply wrong with the whole story? Okay, let's dive into this and see what we can find. First off, why was everyone so excited? What's the big deal with metallic hydrogen? Well, for decades, this stuff has been this theoretical wonder material. If you could actually make it, and this is the key part, if you could keep it stable at normal room temperature, you'd unlock tech that is straight out of science fiction. Okay, so take rocket fuel. This chart shows something called specific impulse, or ISP. Just think of it like gas mileage for a rocket. The higher the number, the better. Our best chemical rockets today max out under 500. Metallic hydrogen, the theory says it could hit 1,700. That's not just a little better, it's a completely different league. It's so powerful it could make single-stage-to-orbit rockets a reality. And that's not even the half of it. It was also predicted to be a room-temperature superconductor. That means it could transmit electricity with absolutely zero energy loss. Imagine that, a power grid with zero waste. So, yeah, you can see why physicists were kind of obsessed with trying to create this stuff. And so, in January 2017, it looked like the moment had finally arrived. Inside a lab at Harvard University, a team led by Runga Diaz and Isaac Silvera announced to the world that they had done it. Just try to imagine being in that lab. They're using this device called a diamond anvil cell, which is basically two perfect diamonds that squeeze a tiny sample of hydrogen at super cold temperatures. And as they crank up the pressure, they're watching this incredible transformation. The hydrogen, which starts out clear, turns black. And then, at 495 gigapascals, that is almost 5 million times the air pressure around you right now, it happened. The sample flashed into a shiny, reflective metal. So naturally, they published this in Science, one of the biggest journals out there. Their data, which was based on how much light the sample reflected, seemed to prove it. They claimed they had created atomic metallic hydrogen, achieving this legendary state of matter that was first predicted way back in 1935. It was, for a moment, one of the biggest scientific wins of the century. And then, it all started to fall apart. Just as fast as it appeared, it was about to disappear. The actual evidence, that one tiny speck of matter, was gone. I mean, just gone. Vanished. A microscopic piece of material, only about 1/5 the width of a human hair, holding the key to a technological revolution, was suddenly nowhere. Get this, just 2 weeks after the paper drops, disaster strikes. The team is getting ready to run some more tests. They aim a low-power laser at the setup, and they hear a click. One of the diamonds, the hardest known material on Earth, shattered into dust. The insane pressure was gone in an instant. And when they looked, the tiny sample of metallic hydrogen was gone with it. Okay, so this raises a huge immediate problem. You see, a key part of the dream was that this stuff would be metastable, meaning it would stay metallic even after you release the pressure. So what if the sample just poofed back into hydrogen gas? That would mean one of its most important, most revolutionary properties was probably just a fantasy. The loss itself was a really bad sign. But a missing sample? That was just the tip of the iceberg. Almost immediately, other experts in high-pressure physics started pointing out some serious issues with the original paper. The scientific backlash was fast, and it was fierce. Remember, Diaz and Silvera specifically claimed they saw this, the Wigner-Huntington transition. That's where hydrogen molecules get crushed so hard, their atoms literally break apart and form a metal. This is the big one. This is the holy grail. Okay, so this is where the scientific community really starts pushing back. First, critics said there's no way to reliably measure a pressure of 495 GPa. They probably overestimated it. Second, they said the data itself, the light bouncing off the sample, was way too thin to be proof of anything. And maybe the biggest criticism, They argued that what the Harvard team saw probably wasn't the legendary atomic metal at all, but maybe a less exciting molecular metal that other labs had already created at lower pressures. For a while, this was just a really intense, technical debate among physicists. But then, the story took a turn, from scientific controversy to something much, much darker. And it all centered on the paper's lead author, Ranga Diaz, after he took a new job at the University of Rochester. So after the metallic hydrogen paper, Diaz went on to publish more blockbuster claims, this time about room temperature superconductors, and one by one, they started getting pulled. As of now, 5 of his major papers have been retracted because of serious questions about the data. And look, the really damning part? These weren't just rivals poking holes in his work. The alarm bells were coming from inside his own team. This retraction notice says it all. A majority of his own co-authors on the paper raised concerns, pointing out that all the questionable data came from one person, Ranga Diaz. It gets worse. An official investigation by the University of Rochester confirmed data had been manipulated in his other studies. His own graduate students came forward, saying he hid the raw data from them, and when they found problems and asked for a paper to be retracted, he actually threatened them with a cease and desist letter. A clear pattern of serious misconduct had emerged, and it cast a very dark shadow all the way back to his most famous claim. So, after all that, where are we now? What does this mean for the search for this holy grail material? The fallout from all these scandals has been huge, and it's forced everyone to go back and take a much harder look at that original 2017 claim. Well, the verdict from the scientific community is pretty clear now. With no physical sample to check, and with the lead author's credibility pretty much destroyed by proven misconduct on later projects, that 2017 paper is just not seen as credible anymore. That glimmer of metal that they saw in the lab, to most people now, it was nothing more than a ghost. You know, this whole story has really become a huge cautionary tale for science. It shows you how the incredible pressure to be first, to get that groundbreaking result, can sometimes lead to a total breakdown of the process. The search for metallic hydrogen will definitely continue, but this whole saga leaves us with a really important question. When the prize is this big, how do we make sure the race to win it doesn't leave the truth behind?